The next presenter is David Milward. He's a Chief Technology Officer at Linguamatics.
Good morning. So I'm going to talk about chemically informed text mining. So just a quick introduction to Linguamatics. So Linguamatics provides the I2E software platform, which is a scalable, real-time platform based on natural language processing. And our customers were particularly strong in the pharma biotech sector, but also increasingly in the healthcare sector and in government, including customers such as the FDA. So what does text mining do? Well, it takes unstructured text. So the text on the right, in the right-hand column, those are example sentences within, in this case, patent text. You're taking those sentences, you're analyzing those to pull out structured pieces of information. So pulling things into separate columns, for example, in this case, using ChemAxon's named structure to interpret the chemicals, assign them a structure, in this case, standardize them back to a standardized IUPAC name to cluster better. In this case, also pulling out the melting points and the values of the melting points. So taking unstructured text and getting structure out of it. So you can then put it into databases, you can cluster it differently, you can visualize the data. So some of the different technologies we use, so we use terminology search. That gives you advantage that when you're looking for something like cancer, you not only find the synonyms such as malignant neoplasm, but you'll also find all the child terms. So you may be looking for thousands of terms, tens of thousands of terms. In fact, you can look for, say, any gene and look for effectively hundreds of thousands of synonyms all in one go. You've got linguistic processing, and that allows you to pull apart the sentences according to their grammar. It gives you meaningful units. And these just give you an advantage that instead of using distance, say, of 5 words apart, you can use the meaningful units given to you by the grammar of the sentence. And that gives you less noise, typically. You can also use it for wildcards. So you can ask for any relationship between P42 map K and We1, and the system can tell you that phosphorylate was one of the relationships. There's also scalable regular expression matching, chemical substructure and similarity search, and the ability to do high throughput searches. So, for example, pull in 500 genes at once and say, for these genes, have a look in the literature, tell us which diseases have already been mentioned in association with these genes. So once you've got more technologies to actually get to a good filter, to get you to the documents and the piece of information within those documents that you want. But also, once you've pulled out that information, you've got it in a structured form, and that allows you to do more with it. You can cluster it, so you can review much more information much faster than if you were doing a search for documents. And we can do, there's various different ways you can represent the results, whether it's in interaction networks where you may be pulling out indirect relationships, looking for, say, going from a particular compound to a particular gene to a particular disease, and finding unknown relationships between them. It could be mind maps or pie charts or trend diagrams. It can be RDF or Bell if you're going to fully structured representations for further inference. So looking at the ChemAxon integration, in the current release, we have the name to structure, so pulling out the chemicals from the text. We have the mole conversion, and then we do some further filtering on that to pull out, to get rid of some of the inaccurate chemicals, generally when people have used the files as drawing packages. For non-chemicals. We then create the I2E index, can query over that with substructure and similarity search. And in the upcoming release, we've also integrated Marvin Sketch. During the last year, we've also introduced a full RESTful Web Services API to I2E, which allows you to build new clients on top of the I2E server. The I2E client uses the same RESTful web services, so it gives you a very fully functioning ability to interrogate the server for both querying, for indexing, for matching classes, and for various administration tasks. And that's become, for people who want to do specialized interfaces for particular scientist portals, for example, for SharePoint web parts, this has become very popular. So some examples here is, in this case, we've got an example where we're taking Thomson Reuters clinical trial data, and then we're adding some extra metadata to that from using the text mining. So in this case, it was looking for sort of reasons for deaths within the clinical trials, which was something which wasn't in the existing metadata. This is an example of taking Excel and from Excel actually calling out to I2E to populate the bar chart dynamically. And the final example, this one's an example of a pipeline pilot calling out from a pipeline pilot component to I2E to populate a bar chart. So we can start to build applications which have the text mining running in the back end. So if you want more information, please visit our stand or also do sign up for some of our webinars. Thank you.